Hey guys, just a quick video here to recover some ideas about classifying functions and relations into one of four main categories. But before I go any further, why the point of classification? Why further describe a function or a relation as something else? If we think back to anything in relation to science, really, why do scientists categorize things into one bracket and something else into another bracket? And it's to help identify or get your mind going that this family, whatever it may be, have certain characteristics. And, that might help us down the track. If we're looking for something that we know contains certain characteristics, we might look for one of these four options very quickly out of the graph to know whether it's ever worth going down that track of testing for any further examples. For argument's sake, coming to mathematics, talking about shapes. Like we have shapes that are classified as quadrilaterals or triangles or polygons. And we can very quickly identify which family they belong to by just counting their sides. And once we know they belong to a family, we know that there are further sets of features that may apply to those shapes. But by just knowing the number of sides, it gives us an idea of quickly what kind of extra features belong to them, what kind of other mathematics belongs to it that will be of use to us. And the same thing here with classifying functions and relations into one of these four categories. So just quickly running through these four categories, that they are classifying how x values map towards y values. So when you ever read any of these classifications, it's always going to, much like reading coordinate points, always going to talk about x first to y. And they're going to be written down as one to one, many to one to many, and many to many. Now, from what we already know earlier, every single function is a relation, but not every single relation is a function. And so what we have here, all those four categories, they are all classified as relations. So any one of these four categories can be determined as a relation. But only the top two, the one-to-one and the many-to-one, they can only be classified as functions. And hopefully you can see that because of this here, that one at the end of it. Remember, for a function to be true, an x must only map to one unique y value. So whenever I have something that goes from whatever it is to one y value, it's a function. And again, like I was saying here in that highlighted part, the main idea is to see how many inputs of our x map to how many different outputs of y. And we're going to use two different tests to clarify them. We're going to look at the results of two separate tests. Now, one of these tests we already know. We know the vertical line test. That's a test that we use to determine if something was indeed a function or not. If it passes the vertical line test, it's a function, because that means the vertical line intercepts a graph only once. And because it only intercepts it once, it passes and it becomes a function. The other one then is to look at, before I go there, and the vertical line test, because it focuses on the y values, it tells us is it too one or is it too many? That's what the answer to the vertical line test. The horizontal line test, well, it focuses on our x values. If our x values, if it passes the horizontal line test, that's 1, 2, whatever the answer was. Or if it fails, it's going to be many 2. So just quickly recapping, the vertical line test tells us our answers to our y values, and the horizontal line test tells us something about the answers about our x values. Now, when it comes to these two tests, if you pass the test, it's to 1 if the test passes. If the tests fail, you'll go ahead and say it's to many. Now remember, with a vertical line test or a horizontal line test, the test must be true. I'll change colors there. It must be true for all of the domain and range. It needs to be true everywhere, from negative infinity to positive infinity, negative. It needs to be true everywhere. If you think about it, hence imagine the line being able to slide up and down the x-axis if it's your vertical line test, the line sliding up and down the y-axis if it's your horizontal line test. Let's go ahead and look at some examples here. So we're going to look at an example of a one-to-one function. And y equals x plus 2 is a one-to-one function, and I'm going to show you how these tests work. The first test, the test we're probably the most comfortable with, is the vertical line test. So I am just going to draw any vertical line. And remember how I said earlier, imagine the line sliding. If I can drag that vertical line anywhere along that graph, that line, and that curve, and it only intercepts it once, we'd say it passes. So anywhere I just drag that line, it passed. So I'm going to say it's passed our vertical line test. Because it's passed, that's going to mean it's going to be 2, 1. So we know this is going to be 2, 1. Now let's look at our horizontal line test. Same thing again with our horizontal line test. Imagine it's sliding up and down anywhere on that graph. And sliding that up, down, anywhere on its graph, it only intercepts once. Because it only intercepts once, we also say that it passes. And because our horizontal line test dealt with our x and it passed, that is a 1, 2. So what we can see here is the vertical line test passed, so it gave us a 2, 1. The horizontal line test passed, so it gave us a 1, 2. Therefore, y equals x plus 2 is a 1, 2, 1 function. All right. I know it's a function because the y is 1. Horizontal line and vertical line test both passed. Let's go through and look at an example of one-to-many. Here we have a graph of y equals x to the power 4 minus 2x squared plus 2x. You can see it's a polynomial. It's a polynomial of degree 4. It's positive, so both arms are up. And again, we're going to look at our vertical line test. So our vertical line test, again, if I drag that vertical line test anywhere through that graph, what we can see is that at any point on that curve, it only intercepts the line once. Because it only intercepts the line once, it passes. So that means it is a 2, 1, something 2, 1. Now we need to look at the horizontal line test. And when I look at the horizontal line test, here I can see immediately where I've drawn it, that horizontal line, it intercepts the line in more than one spot. It crosses the curve in many positions. Everywhere along that curve, it crosses it for many positions, except there at its turning point where it crosses once. But it doesn't matter, because remember we said it needs to be true for all aspects of the domain and range. And when I start to slide it up, it intercepts the curve at many positions. So our horizontal line test fails, meaning it is a many 2. So this polynomial of degree 4 is a many 2, 1, and it's a function. And remember, it's a function because it's passed our vertical line test. We continue on and look at what a many to 1 is. All right, so this is a graph of x equals y cubed on 4 plus y squared minus 1. If you think about it, it's just a cubic curve, but I've turned it 90 degrees to the right or left, whatever way you want to look at it. Yeah, it's been turned to its side. So if we have a look at this, let's do our vertical line test. So I draw my vertical line. Now I realize I can slide this on my iPad. In your test, get a ruler. Hold a ruler up to the screen or to the piece of paper and slide that ruler across the entirety of the graph, and gives you the exact same effect. So sliding this vertical line, I can see that there are some points where it intercepts the curve in many positions. So my vertical line test fails. So this is something that is too many. If we look at the horizontal line test and we move our horizontal line, anywhere on this curve, the horizontal line only intercepts it once. Because it only intercepts it once, it passes. So it's a 1, 2 something. Combining our two tests, we get a 1, 2 many, and it's a relation. Remember, it must be a relation because it's failed the vertical line test. And finally, a many to many. Now, hopefully by now you can see that this circle here immediately is going to fail the vertical line and horizontal line test. Remember, again, it needs to slide and be true everywhere. At the very edge of the circle, it touches it in once. But if we continue it along all of its domain, it crosses it many. So our vertical line test fails and is a too many. In the same way, our horizontal line test will also fail. Because it's failed, it is also too many. Therefore, this is a many to many relation. All right. We've just quickly gone through the 4 examples of how we classify functions. And the way that we classify them is that we use our vertical line test and we use our horizontal line test. Remember, with both tests, if the test passes, it is 1. The vertical line test passes, it is 2, 1. If the horizontal line test passes, it is 1, 2. Horizontal line test always tells us information about our x. The vertical line always tells us information about our y. If both tests fail, it's many to many. Combine what we've got. I've just realized I've made a mistake. That should actually read many to. All right, hopefully that is clear for you guys. If it is not, please shoot me an email, get back to me, get in touch. I'll come up with something different and try and explain it again. I have a bunch of questions for you to do at the end of this PDF, as well as I've included the solutions for you as well. Please go through, get these done. Any questions, email me. Again, it's all about focusing on the tests. The vertical line tells you answers, tells you something about the y. Horizontal line, it tells you something about the x. If it passes, it's 1. If it fails, it's many. Good luck with it, guys. Let me know if there's anything else with that through emails, and we'll get back to you later. Cheers.